Thank you for coming to view this presentation. During this time, we will be showing you some of the recent advancements of our tool, Dynamic Interactive Views for Reverse Engineering, or DIVR for short. The goal of DIVR is to transform the familiar integrated development environment into a tool that is not only for producing software, but for understanding software. We'll begin by demonstrating some of the most basic features of DIVR using simple game of Tetris, which can be started by using the standard Eclipse Run menu. DIVR is designed to help developers understand their software from a functional point of view. That is, what is my software doing? For example, we may want to know how this Tetris game goes about turning a game piece, such as the one seen here. Let's do it the DIVR way. DIVR gives its users a view into their software by allowing them to gather runtime information in the form of dynamic execution traces. This is done using a simple button contributed to the Eclipse debug view. Since we are most interested in the way that a piece is turned in the game, that's all we're going to make the game do. After that, we'll pause the trace, close down the game, and in a few seconds, DIVR will have stored the data for us. This will take a few seconds, but once the data is stored, we'll be able to see it in DIVR's custom Program Traces view. The traces are listed in order of the name of the launch that they were recorded using and the date that they were recorded. From here, we can see the threads that were recorded for each trace. Our Tetris game had 2 threads with data in them. We can view a thread using a custom sequence diagram view. The DIVR sequence diagram view is fully interactive and designed to help people understand the software behavior. However, looking at a large sequence diagram can be just as cumbersome as looking at a large amount of source code, so DIVR offers a little bit of help. The technique that DIVR uses is called the trace-focused user interface. By selecting a small yellow icon beside a recorded trace, we can activate the trace and affect the user interface of the Eclipse IDE so that it highlights the information pertinent to the activated trace. It also links the Java structural views, such as the Eclipse Package Explorer, to the sequence diagram view. For example, right-clicking on a method allows me to view the first time that that method is called. We can see, for example, the doPauseGame method called here. And we can see that it is called exactly once by looking at the timeline here. We'll notice, though, that doPauseGame is not likely a part of the turn piece functionality that we started off investigating. Our trace contains noise that we aren't really interested in looking at. DIVR offers a way to get rid of the noise. To do that, what I'm doing is running the Tetris game again. I start recording the trace, but this time I do any action other than turning a game piece. The purpose of this exercise is to create a noisy trace that can be used as a filter on top of the trace that contains the feature of interest. This technique is called software reconnaissance, and it can be very effective in helping us to focus the software artifacts that are unique to the feature of interest. To enable software reconnaissance, we make use of a small eye icon that can be seen in the Program Traces view. Clicking on the eye closes it and filters the Package Explorer down to one method, rotate counterclockwise. This is the method that we are interested in. We can gain further insight about the functionality of the method by opening it in the sequence diagram view and reading the program execution. The DIVR sequence diagram shows us the context of all the method executions surrounding our method, including code blocks such as loops and conditionals. New to DIVR is the ability to filter out the sequence diagram as well as the Eclipse Package Explorer. By looking at the sequence diagram here, we can see a number of methods that were called in the context of the rotate method, but may not be unique to the turn game piece feature. DIVR now offers the ability to filter out such method calls. If we compare the Program Traces view to the sequence diagram view, we can see that they both have a similar eye icon. Clicking on the eye in the sequence diagram view synchronizes the view to the software reconnaissance features defined in the Program Traces view. Here we see that a number of methods have been grayed out in the diagram, indicating that they are not part of the turn game piece feature. DIVR also makes it possible to remove these method calls from the view completely. After several seconds, the view will refresh and show us that this diagram can be reduced to a mere 3 method calls. We can also hide the conditional blocks from view to give a cleaner look. New to DIVR as well is the ability to highlight all of the Java structural views in the Eclipse IDE and not just filter the Package Explorer. For example, I can turn off the filters in the Package Explorer here. Now, all of the software in my workspace is visible, but the artifacts that are pertinent to the feature of interest are displayed in dark text, and so they are easier to find. Now,
I can find the artifacts that are unique to my feature, but I can also see the rest of the software, which may help me to make inferences about the context of my feature. For example, what other classes are included in the same modules. When I open the class in the Java editor, I can see that the trace-focused UI affects other views as well. Over here is the Java outline. As in the Package Explorer, the methods that are unique to our feature are highlighted. The others are faded, indicating that they may be of less interest. One final new and related feature that I would like to demonstrate is Diver's new ability to integrate with Eclipse's Java code search. Here we can see the source code for a large open source Java web application. Suppose, for instance, we are interested in knowing how its login feature works. In the interest of time, I've already created several traces that we can use to try and focus our investigation on the login feature. Due to the size of the application, it will take a little extra time for Diver to initialize its trace-focused user interface. Once that is completed, we can use software reconnaissance to filter the Eclipse Package Explorer. However, we can see that, though the number of visible packages has been reduced significantly, there is still quite a bit of code to look through. Perhaps there is another way that we can do this. Let's try code search. Using the Java search menu, we are presented with a dialog that allows us to enter some keywords. We choose to search for references to methods. That is, we'll try to see where methods with the name login are called, and we'll look at the results. We can see here that there are 152 references to methods containing the keyword login. The task of browsing through all of these calls seems daunting. This is a common problem with code searches. The results from the search and the results from software reconnaissance both seem to be too large to be useful. But if we combine the results, their combined power can really help us to hone in on what we are looking for. After re-enabling the trace-focused UI, I can rerun my Java search. Here, we see that the method references that are unique to the login feature are highlighted. In fact, only 11 of the 152 results are pertinent. Seeing this view makes it much easier to find the important method calls. Now that we have found the important method calls, we can start analyzing them in the sequence diagram view. That can be done directly from within the searched results. Right-clicking on a method allows me to open the sequence diagram on the first call to that method. Again, due to the size of this program and its corresponding traces, it takes a little more time to open the view. However, once that is complete, we can begin our analysis and learn about the behavior of the login feature. Diver is a research collaboration between the Chisel Group at the University of Victoria and Defence Research and Development Canada, with support from the Natural Sciences and Engineering Research Council of Canada and IBM. It is available for download as free and open source software. For more information, please see our website, diver.sf.net. Thank you for viewing this demo.